let's take a look at the domain over which we need to, solve our governing equations. And the domain looks like that. Let's understand what that is. That's my radial coordinate. That's my axial coordinate. That's the pipe wall. And this is the axis of symmetry. I have flow coming in here. So that's the inlet. And I have flow leaving here. So that's the outlet. That's equal to, so that distance is equal to the radius of the pipe. So that's going to be half the diameter. And that distance is going to be the length of the pipe that we are simulating. So the radial coordinate can go between 0 and r. So that's a range of the radial coordinate. The axial coordinate can go between 0 and the length of the pipe. Now, in a 3D problem, you would also have the circumferential coordinate, and that can go from 0 to 2 pi. However, in this case, we don't have any dependence on the circumferential coordinate. So if I take this rectangle and revolve it 360 degrees about the axis, I'm going to get the full pipe geometry. But because of the axis symmetric assumption, we are assuming that whatever the angle of this rectangle is as I'm revolving it about the axis, the solution is going to stay the same. So I can knock out any dependence on the circumferential coordinate. And students get confused, and I did too initially, that your domain, it doesn't look like a cross section through the pipe. It looks like it's half of that cross section. But once you understand the axisymmetric assumption, it makes sense. One thing to keep in mind is that in Fluent, the axial coordinate is called x and the radial coordinate is called y. So when we are in the solver, we will mentally substitute that x is the axial direction and y is the radial direction. So that's the domain over which we will solve the governing equations, and we need to supply boundary conditions at the edges of that domain.